To my video on scatterplots. So scatterplots illustrates the relationship between two sets of numerical data represented by two variables. So a scatterplot will, each point may represent an independent and dependent variable. So remember, the independent variable is graphed on the horizontal axis and is the x, and the dependent variable is graphed on the vertical axis or the y. Okay? And scatterplots are used to predict linear trends and estimate a line of best fit. Okay? And we'll talk about what a line of best fit is down below. So a correlation is how the two sets of data relate to each other. Okay. So here we're going to be comparing the wife's age to the husband's age. So as the wife's age increases, the husband's age is also increasing. And look at this. It's following a positive relationship here. So this is a positive correlation. Just like when we did slope, if it sloped up, it had a positive slope. Same thing here, it's a positive correlation. They're both increasing. Now here, as one set of data decreases, the other set of data is increasing. Then this is an inverse relationship. So this is a negative correlation. So a good example would be your math grade, maybe on a quiz out of 8 problems, and the hours playing video games. Okay, so as the hours of playing video games goes down, your math grade increases. Or you could also say as your math grade increases, the amount of hours playing video games decreases. Okay, so let's move right along here. Now here we have the price of a product and the quality of a product. And as you look here, you can't see any sort of relationship here. So we call this no correlation. Okay, as your quality increases, your price is not really related. The price is kind of all over the map here. So it could be very expensive and not have very good quality, or it could be very expensive and have pretty good quality here. Okay, so there's no real relationship there. This one, okay, you can see here, all of them are kind of staying together, but it's not increasing, it's not decreasing. They're kind of staying steady. This is called a constant correlation. And a good example might be the days in July and the temperature. Okay, so you'll notice as the days in July increase, the temperatures stay pretty much the same. We'll call this 85. And we'll call this 90. So all the temperatures are staying between 85 and 90. So this is a constant correlation. Okay, this brings us to the line of best fit here. And the line that can be drawn to best represent the data in a scatterplot. So what does this tell us? It helps in making interpretations and predictions about the data. So if you look here, as the wife's age increases, husband's age increases. We looked at this before. And this is a positive relationship. And the line of best fit would kind of run towards where most of the data lies. And so typically when you draw your best fit, there's the same number of points on each line of the best fit. So it kind of goes through the center of the data here. Okay. Now this one, line of best fit, as this one decreases, this variable increases. Okay. And so your line of best fit would go right about here. And you can see there's about the same number of points on each side. There's 5 here, and 1, 2, 3, 4, 5 here. Okay? And remember, this is a negative correlation here. And then this correlation, remember this was no correlation, and the line of best fit, let me get the tool here, would kind of go towards middle of the data here. So there's about the same amount on each side here. Okay. Now, the scatter plot, turn to the back here. The scatter plot shows the comparison of errors made on a final exam to the number of hours studying. Okay. And this is right here is the time spent studying. It's very difficult to read here, so we might write it again here. Time spent studying. And here, the number, let's say number of mistakes made. And I know it says it on your paper here, but it's very difficult to read. So let's see, the more time spent studying, the more mistakes. Let's see, more time spent studying, the more mistakes. No, it looks like there's less mistakes the more times. So less time spent studying means less mistakes. No, it looks like the most mistakes are here. So more time studying means less mistakes. Yes. Because look, as the time spent studying increases, the number of mistakes goes down. Okay, let's look at the next example. This set of ordered pairs is graphed below. 3, 12, 5, 10, 8, 7, 9, 5, 11, 2, and 14, 1. Which of the following graphs shows the line of best fit? And if you look here, we're looking for a negative correlation because these are trending down here. As this increases, this one's decreasing. So that's a negative. So we're looking at either, I can cross out C and D because those are positive. So it's either A or B. And if you look here, if I were to draw in this line of best fit here, right about there. Okay, we would be looking for the steeper of the two, which is choice B. Okay, and our third and final example here. Which of the following situations could represent a negative correlation? Remember, one, we're looking for a situation where one increases and the other decreases. So the first situation, miles traveled and how many gallons you have in the tank. So as your miles increases, what happens to your gallon of gas? It goes down. So that would be one positive, one negative. So yes, that is a negative correlation. As one increases, the other goes down. Frequency of absences and scores on the math test. So as your absences goes up, what might happen to your math score? It would go down. So yes, this would be a negative correlation. One increases, the other decreases. The amount you eat and your weight. Well, the more you eat, the more your weight's going to be. So they're both going to increase. So no, not this one. Okay, number of pictures on your phone and the amount of data you have. So as you take more pictures, are you going to have more data or less data? Good, less data. So as your number of pictures increases, your data amount of data available is going to go down. So that's a negative correlation. The relationship between pre-assessment and post-assessment scores, usually what's going to happen on your pre-assessment? You're going to get lower, and on your post-assessment, you're going to get higher. So your post-assessment score is going to be a lot more than your pre-assessment, so it's going to increase. So that would not be a negative correlation. And finally, the height of a tree and the amount of carbon dioxide in the air. As your height of the tree increases, there's going to be more carbon dioxide in the air. So that's positive, so no. All right, that concludes our notes on scatterplots. I hope you have a great day.